Good evening. Good evening, everyone. On behalf of Nehru Planetarium, Nehru Memorial Museum and Library, it's my pleasure to host this session on basics of amateur astronomy and stargazing for the personnel and families of the Indian Navy and other armed forces. Amateur astronomy is a wonderful field for everyone to pursue, and today's session would help you in taking the first step towards this and going forward. And I'm also hoping that from the planetarium, in as we go along, we will do celestial navigation aspects and quantitative aspects. Today's sessions will be conducted by Captain Anil Kumar ji, a keen amateur astronomer and photographer who has been working tirelessly towards popularizing this hobby among the beginners. The officer has been holding live astronomy and stargazing sessions, which have gained a lot of popularity. And I have been also interacting with these beginner groups along with Captain Anil Kumar, and it's been a real pleasure to see the kind of enthusiasm which has been generated. And I'll hand over to you, Anil ji. I will put up your screen share as well. And the questions, they can be put in type. However, the speaker would not be able to see them until the session is completed. I will also take up answering some of the questions, and speaker would take up towards the end. Captain Anil, I will hand over to you. I will add your presentation into the stream. It is now visible. Presentation is visible. I'll hand over to you.
Uh, Thank you, ma'am. Am I audible?
Yes, yes.
Good evening, everyone. First and foremost, I wish to thank the Indian Navy and Nehru Planetarium for providing me this opportunity to communicate with you all and share my experience in the field of amateur astronomy. My love affair with astronomy started way back as a young cadet on board a naval training ship when I was taught astronavigation as a discipline for fixing the ship's position by taking the sextant readings of the heavenly bodies. Now, night sky had always fascinated me, and somehow astronavigation and the teaching of that complemented what I always aspired to do. I had always aspired to do from my childhood days. Now, this passion grew into a full-fledged hobby about 6 years back when I bought my telescope. Now, since then, I've been spending endless nights gazing through my eyepiece of my telescope, and I've also conducted many astronomy and stargazing sessions for beginners, making them understand the nuances of amateur astronomy and sky gazing. For today's webinar is packed at people who are absolute beginners, who don't have any concept of astronomy so far. So I will try to introduce the concept to you gradually and thereby initiating you into the world of amateur astronomy by providing the initial thrust and direction. Thereafter, it is for you people to progress in the hobby on your own because amateur astronomy to a large part remains a self-taught discipline. Now, my emphasis during the talk would be on the visual observation of skies by the naked eyes, as well as well as with the help of some basic equipment, which is not very costly and is easy to procure. Now, when we talk of astronomy, the picture that comes to mind is of big telescopes, high power, cameras, and sophisticated gear. And also, you have to involve into large amount of calculations, refer to many almanacs, and so on. However, that is not true anymore. Technology today has simplified the hobby a lot and brought this hobby well within the reach of the ordinary people. Or you can start following amateur astronomy from day one without investing in any special gear or equipment of any kind. You can start contributing to the science as citizen scientists again from day one without any special training or learning. All you need is a smartphone, which almost everyone has got, or a laptop and an internet connection. Understanding a few basic concepts, and you are ready to embark on a journey of a lifetime into this fascinating field of amateur astronomy. Now, I would be talking about these things later as we proceed. Now, as you know, uh, Astronomy relates to the field of the universe or study of the universe, and this may well be the oldest science in the universe. We can say that it started from the moment the early humans started observing the sun, the moon, the stars, and planets, and the patterns these objects made in the sky. Soon, the life of human beings became excessively dependent on the observation of night sky. As man progressed towards agriculture from hunter gatherer way of life, heavenly bodies started telling our ancestors what crops to sow and harvest at what time. It guided them to undertake navigational voyages over huge land and sea areas and pretty much controlled almost every aspect of their lives. In a way, our ancestors started observing the night sky much more than what we are doing today and started understanding the mysteries of universe based on pure naked eye observation. So the astronomy continued to evolve as an observational science and proceeded at the level of pure observation for thousands and thousands of years before it finally crossed the threshold from the prehistory into the history when we started recording various observations. We can say that when the Sumerian civilization of Mesopotamia invented writing about around 3400 BC, they invented history as well. Now, that was the time when astronomical observations, like many other facets of life, started getting recorded. Mesopotamians led the world of astronomy for thousands of years before passing the mantle to ancient Greeks in about 500 BC. Now, this was the time when the scientific thought and theories started getting formed based on the observations, and the modern astronomy, in a way, started getting shaped. Now, a lot of work was done by the ancient Greek philosophers and thinkers in the field of astronomy, again, based on the pure naked eye observations of the night sky. The famous mathematician Pythagoras coined the term cosmos in about 500 BC, which is used to refer to the underlying harmonious order of the universe. Now, another Greek astronomer, Aristotle, gave us the first model of the universe, which was essentially a geocentric model with Earth shown in the center of the universe. You would notice that this model, though factually incorrect, has got the order of planets, sun, and stars totally right as observed visually from the Earth. You can see the Earth in center, then you see the Moon, Mercury, Venus, Sun, Mars, Jupiter, Saturn, and thereafter there was the fixed stars and sphere of what they call the prime mover. Now you see all these objects were not only identified with the naked eye way back in 500 BC and way before that, but they also knew their relative distance from Earth, and they were able to put them in the relative order of distance on this particular diagram. So, interestingly, another Greek astronomer named Aristarchus of Samos disagreed with Aristotle's geocentric model. Now, this was about the same time. He was there about the same time when Aristotle was there. Now, Aristarchus observed the Earth's shadow on Moon during a lunar eclipse. And he was able to determine that Earth was not in the center of the universe, but it was like just a planet which went around the sun along with other planets. He also was able to discern that the Earth rotated on its axis every 24 hours. So his ideas, though revolutionary and factually totally correct, were unfortunately rejected at that time, and Aristotle's geocentric model was adopted as an explanation of the order of universe. This model of Aristotle, the geocentric model, was also adopted by the church during the Middle Ages, and Earth as the center of universe became the popular religious belief as well. Now, this status quo was not to be challenged for the next 1800 years. Aristotle's geocentric model ran into a problem though when it came to what is known as the retrograde motion of planets. So this phenomenon takes place by virtue of relative speed of Earth's rotation around the sun with respect to other planets, and is difficult to explain by the geocentric model. Now, in this diagram here, we have the Earth which is going around the Sun. And let's say we have Mars here. Now, in the first position, when we're looking at Mars, Mars is being seen at position alpha, small a. As Earth moves up, we see Mars in position V. Then suddenly we find Earth overtaking. Mars goes to C, then start going back D, E, F, G, and so on. So essentially, from the perspective of an observer on Earth, Mars is making one circle in the sky and then moving up again. Now, this is very difficult to explain if you have to keep Earth in the center of the universe. However, it is a very simple thing when you look at Sun in the center of the universe and see Earth going around the Sun like other planets. But this was something which was not understood, and Aristotle's model was not able to explain this phenomena. Now, this fix to the problem in the geocentric model was offered by another Greek and Alexandrian astronomer and mathematician, Ptolemy, in the second century AD. Ptolemy brought in the concept of epicycles. What he said was that all the planets not only go around the Earth, in the orbits, but they also go around small circles in the orbits, which he called epicycles. Now, this concept of epicycles made the model very cumbersome, but it provided a satisfactory explanation for the retrograde motion which was being observed from Earth. Now, this explanation of Ptolemy was lapped up by everyone, including the church, and Earth again officially became and came to stay in the center of the universe in the scientific thought of the day for about next 1200 years. No, it was in 16th century AD, about 1200 years after Ptolemy proposed the theory of epicycles, when Copernicus proposed the model, a heliocentric model, in which he said, look, it is sun indeed, which is in the center of the universe. What he essentially said was that Ptolemy's epicenters were getting untenable. There was no scientific proof, and no, there was no fixed method how to draw these circles around the planets. Every planet seemed to have its own circle, and the model was becoming very cumbersome. So what Copernicus said was that a heliocentric model, if we go to a heliocentric model now, this would be a better proposition and an elegant solution rather than going by the geocentric model with epicenters on it. However, it was not until 1609 when a man called Galileo Galilei turned a newly invented instrument called telescope to skies and observed actually indeed what was happening with the Earth and other planets. And he started a new phase in our understanding of the universe. Now, by turning his telescope towards the heavens and observing the moons of Jupiter, rings of Saturn going around their respective planets, Galileo inferred that everything in the universe was not going around Earth as was being believed that time through religious thought as well as through the scientific thought of the day. Now, close observations of moon revealed that it was not a perfect heavenly body as the scriptures of the day would make people believe, but it was scarred and had pits and craters. And finally, when Galileo observed the phases of the Venus over a period of time, he got the final proof that it was indeed the sun and not the earth which was in the center of the universe. Thus, Galileo's observations discredited the standing Aristotle and Ptolemaic system and supported the Copernican system. But as the geocentric model had already been adopted by church for past thousands of years, Galileo's work brought him in direct conflict with the popular scientific and religious thought of the day. Galileo published a book called Starry Messenger in 1610, in which he gave a proof for his heliocentric theories. Now, this led the church to use all his might in silencing Galileo. He was forbidden by church for teaching the heliocentric beliefs and also was threatened with torture and asked to recant his work. And finally, in an event which is recorded in history as Galileo's Inquisition. Galileo was made to recant his work totally, and he was asked not to uh, not to propagate his heliocentric belief any further. After this, Galileo was put in house arrest and was forbidden for life from spreading any ideas regarding the sun being in center of the universe. However, further away from Rome, a contemporary of Galileo, or at the same time, a German astronomer called Johannes Kepler was working in a pre-telescopic observatory in Czechoslovakia as an assistant to another astronomer whose name was Tycho Brahe. Who was studying Brahe's precise planetary observations. Kepler was able to formulate his universal laws of planetary motion, which remain applicable even today. However, in spite of giving very elegant laws of planetary motion, the Kepler was not able to explain as to why the Earth or the planets they are going around the sun in the first place. Now, this explanation was provided by Newton, who said, who famously observing an apple falling on the ground, gave his laws of universal gravitation, which applied universally to the solar system as well as to all other heavenly bodies in the universe. After Newton, Einstein explained the effect of gravity through his theory of warping of space-time, wherein time was referred to or treated as a fourth dimension, in which Einstein wove a fabric of space-time which pervaded the entire universe. As per Einstein, the warping of or depression in the fabric of space-time, which is shown here in this diagram, uh, uh, so this warping, as per Einstein, was due to addition of a big mass, which is shown in yellow here, in the fabric of space-time, which makes the other objects go around the greater mass. So basically, there is a depression which happens in the space-time continuum, and because of depression, a smaller mass will start going around it. This example can apply to Earth or the planets going around the Sun, or for that matter, Moon going around the Earth. Now, by this theory, Einstein explained gravity not as a force, but as an effect of the motion of heavenly bodies around a bigger mass due to warping of space-time. Later, through a phenomenon called gravitational lensing, Einstein proved that warping of space-time not only resulted in heavenly bodies like planets going around heavier masses like Sun, but also had an effect on propagation of light. The proving that light from the distant stars and galaxies gets bent due to presence of other stars and galaxies on its way, which is shown in the diagram here. Einstein was able to provide a completely different understanding of the working of the universe. And finally, it was Edward Hubble's observation of an expanding universe, which, when taken backwards in time, brought us to a point of singularity in space time, thereby giving the proof of the theory of Big Bang. Also, the latest observations of unaccounted for mass leading to the amount of gravity to hold the galaxies together and the unknown energy which is resulting in the expansion of the universe, as was observed by Edwin Hubble, brought new concepts of dark matter and dark energy, which are still being studied. Now, thanks to the work being done by Edwin Hubble, today we know that universe as we see today resembles the surface of an ever expanding balloon, every point in which seems to be moving away from each other. In such a scenario, with no specific point which can be considered as center of the universe, every point in the universe from where you start observing it can be treated as a center. So this brings us back full cycle to Aristotle in 350 BC, who said that time then Earth was in the center of the universe. And we can say that Aristotle was after all not totally wrong at all. So we have seen how the visual observation of skies has molded the history of science and the scientific thought for a long time. But today, it is a dying art. Most of the people today are unaware or of even the basic directions. I won't even know which side their house is facing unless some Vastu expert or some Jyotishi comes and tells them this. But we need a GPS to step out of our homes and drive even over a short distances. Increasing light pollution in cities has made our skies much less darker, leading to far lesser number of stars and other objects to be seen. High-rise buildings and towers have further reduced the share of open skies we have access to. Lack of dark skies and dark spaces in the vicinity of residential colonies and societies, fast-paced life, leaving very little time to pursue meaningful hobbies, have further dissuaded people from indulging in otherwise very rewarding hobbies like amateur astronomy. However, pursuit of astronomy has always been the direct way of connecting with cosmos in its purest form. In addition to increasing scientific temper and contributing to citizen science as a citizen scientist, the joy one gets while observing the heavenly bodies through the eyepiece of a telescope is difficult to explain. It remains one of the best proven stress busters to date. So, this brings us to a kind of conclusion that uh, the pursuit of amateur astronomy is a worthwhile pursuit, and if we have time, we should come out of our houses and start looking at the sky slightly more. For that, we come to something which I am calling the beginner's corner. Now, here we will discuss the what, when, where, and how of astronomy. Thereafter, we will discuss some of the equipment which is required for pursuing the hobby, which is basically to aid to the naked eye, and also some tips and tricks to make the most out of this equipment. Finally, I would be glad to answer the questions if you have any, along with the moderator, Dr. Rathnasree. So I've compiled the basic questions that a beginner in the hobby confronts in what I call the four W's and how of astronomy. These questions are when, where, with what to start with the hobby, and what to see in the night sky, and how to go about doing it in the first place. Now, with regard to when to start, I think any age is good to start this wonderful hobby. I often find parents very keen to send their children to me for astronomy and stargazing sessions when they themselves have never got a chance to see through the eyepiece of telescope. But I have also observed that the adults and the elderly people get equally fascinated and overjoyed by the hobby once they get into it. So, as per me, any age is good to start, and the right time to start is right now. Now, by virtue of attending this webinar, you have already taken the first step towards beginning with the hobby of amateur astronomy. And after the completion of the session, most of you would be equipped to take on the hobby totally on your own, right from the comfort of your homes, without any need for any specialized equipment. So, when it comes to what to start with, the answer is naked eye. Only after you have become sufficiently familiar with the night sky, with the naked eye observation, that is, after many sessions of naked eye observation, using the tools which are freely available to assist you, you should be opting for the specialized equipment like telescopes or, for that matter, even binoculars. You have to understand that binoculars and telescope have their specific role and purpose, and they cannot replace the naked eye observation at all. So it is not that first you have to see through the naked eye, thereafter you go to binoculars, start seeing something more, and telescope. It is a two in a way. But what you can see with the naked eye and observe with the naked eye cannot be observed or seen with binoculars or telescope. So everything has got a different purpose when it comes to field of astronomy, and the naked eye comprises about 70% of the work which you can do while pursuing the hobby. Now, the first step towards starting your visual observation is getting familiar with the night sky and getting your spatial orientation correct. Now, for familiarization with the night sky, there are various tools which I'll be discussing in the next slide. As regards spatial orientation, unless you otherwise know the directions, you can use the compass on your smartphone to find out the true north and then rest of the directions. Now, if you are staying in a flat, it will give you some idea as to which part of sky you would have an access to during the night sessions, or through your balconies or your door or the terrace or whatever. And next, you would also need a night sky map or a star chart, which will show you that for your latitude and the time of your viewing, what all is going to be available in the sky. Now, this can be easily done with the help of a very basic tools, which I will be showing you in the next few slides. And finally, once you have seen the chart and you know there are objects in the sky which are as the chart, still you need some kind of a tool to assist you as to understand whatever you see in the sky is actually indeed what is shown in the chart. That means you would like to know whether the star you're seeing on top is a planet or maybe a star, and if it is a star or planet, what is the name. So for that, there are some very basic mobile apps, which again I'll be telling you. So if you have a chart with you, which I'll show you how to take a printout of or take a small screenshot of, and you have a mobile app with you, you have to only step out of the house, look at the sky as per the chart, thereafter turn your mobile towards the sky and confirm the name of the object in the sky. And this will straight away tell you what you are seeing in the sky. And after that, once you get the first peg, once you get a first anchor, let's say you identify Jupiter in the sky, thereafter it's a simple map. When you go left as per chart, you should be able to see second object, which you're going to find a name of. And thereafter, in one night itself, you would be able to see at least, let's say, 60 to 70 stars and identify them positively with the help of an app which you have got on a mobile phone. So no other equipment is required. With these simple tools, you are able to navigate through the sky very beautifully. This is what I'm going to now explain to you in the further slides. Also, using the stargazing and star hopping techniques, which I told you, star hopping basically is once you identify one particular star or planet in the sky, from there you start moving the sky. You can say, okay, fine, now I move left. The next bright star is so and so. And from there, if I move down, this is what I'm going to see. So this is basically your stargazing and star hopping. As you hop from one star to other star, you are able to navigate through the entire night sky and able to identify all the objects which are there to be seen. Now, before I go further, the tools I mentioned, there are certain websites which are shown on the slide. The first is Sky and Telescope, which is the American website, which will give you almost all the tools free to start with the astronomy. Then there is Skynet magazine. It's a website from UK. It is also a very beautiful website. It will also give you a lot of information, something just like Sky and Telescope. Then there is a website called Stellarium Web. Now, Stellarium is something like it's like a planetarium. It will show everything to you on your computer screen or on the mobile phone as to how the night sky is there right now and how the things are going to progress with time. You can simulate time-lapse movie in that. You can increase your time and you can see the things moving, and you can go backwards. You can do many things. So it gives you
Uh,
the very clear simulation of how you're going to see things in the night sky as you go out. After
Captain
that, there are
Anil,
the white apps which I
there is,
mentioned here. Out of
there is
this,
a
I personally
request.
use SkyMap and Skyview, and I also use Stellarium, which is basically a paid version. So if you download any of these, you would be good to start your session tonight. So I will pause on the slide for a while. You can note down if you want, or take a photograph of this particular slide, and you can start downloading this software.
There was a request from one of the viewers, Captain Anil,
Yes, ma'am.
for a repetition of the previous explanation. There was a
Uh,
request from one of the
okay,
viewers
okay.
to.
So you're talking about naked eye, ma'am?
Soumya Koshal, you said please explain this again, sir. Yeah, probably, yeah. If we could just the very beginnings, how to get started, a little bit of repetition, if that could be done. Usage, I think, of the software was
Okay,
where I.
I'll come there. Okay. So basically, the software you can note down the names of the software of the various websites and mobile apps. I will be going to a live simulation wherein you will be able to see the software yourself. So if you note down this and maybe you can download this stuff. It's very simple websites. You can straight away open a browser and open these websites. And mobile apps you can download. You can download only one, which is Sky Map, which will see you through for most of your sessions going forward. But before I go to the night sky simulation, I would like to speak about something about the stellar magnitudes. It's important to understand the concept of this particular concept. Now, the magnitude is basically a measure of how bright an object would appear to you in the sky. Now, lower the value, the brighter the object. For example, if you see sun here, which is at 26 minus 26.74, this is the brightest object we can see in the sky from Earth. As we move to moon, it is minus 12. Venus, the brightest planet, when it is brightest to us, is minus 4.7. The brightest star in the sky is Sirius, which incidentally can be seen these days somewhere around, let's say 11 or 12 in the night. You should be able to see Sirius along with the constellation of Orion. Now, Sirius is at minus 1.46. Pole star is plus 2.2. And the naked eye limit of observing the visual sky with the night sky is somewhere around 6.4. And thereafter, you go further, you see Hubble telescope, which is around 28, which cannot be seen with the naked eye or even with the, let's say, a telescope. Now, this magnitude, which you see here, is apparent magnitude, which is mentioned in the x-axis below. Sorry. Okay, so the stellar magnitude is actually of two types. First is the absolute magnitude. Now, this is nothing but it is based on the intrinsic brightness of a star as to how bright the star is. And then comes the apparent magnitude, which takes into account not only how bright the star is, but how far the star is. Now, it's quite possible that a star is very, very bright, but it is very far off. So, you will see it as a star, whereas the sun, which is much smaller than those stars, appears very big. So, apparent magnitude is a combination of the intrinsic brightness of the star and its distance. And that is what actually matters most to us. Now, a third term you'll come across, which is called the limiting magnitude. Now, limiting magnitude is nothing. Let's say your apparent magnitude of a star is, or something is minus 1.46. But now let's say the area you're observing from has got a lot of light pollution, like it is there in Delhi. Like yesterday night when I went out at 12 o'clock, I could not see anything in the sky. Not even Mars, not even Sirius, which is the brightest star, because my limiting magnitude was much lesser, maybe minus 4, minus 5. I could barely see the moon in the night, which is at minus 12. So limiting magnitude is basically as per the prevailing conditions, light pollution and other pollution, which limits the seeing of the heavenly bodies in the sky. But you have to understand the apparent magnitude is a key, which will tell you as to what you can see through the naked eye on a clear day. Okay, whilst now taking you through a star hopping and stargazing simulation, I would also try to explain the concept of star hopping and stargazing through an example. I've already explained the procedure to you using a packed star and going ahead. This I'll show you live as I go for simulation. Now, star hopping and stargazing can be very useful for locating very dim stars or planets in the sky. Now, we all know that we can see the 5 planets with the naked eye, the first 5 planets. However, Uranus can be seen only through the help of binoculars. And for Neptune, you have to actually go to a telescope. But even if you look at Uranus through binoculars, you only see a very dim star, which cannot be distinguished from other stars. So in the huge field on top, when I start looking, when I see a very, very small, dim source of light, there's no way of knowing this is indeed Uranus. The only way I can do it is if I'm very sure Uranus in the vicinity of other stars. That means I do star hopping. Go from one particular bright thing, which I know for sure, let's say Mars. From there, I start going down, start seeing all the stars which are shown on the chart, actually in my binoculars. Then I reach Uranus. And I know for sure that in this particular field, what I'm seeing are, let's say, A, B, C, three different stars, and the fourth star which is there as per chart is Uranus. Once I do that, the same thing I can apply to my telescope, and I can move the telescope from the peg star or planet to other stars and reach where I want to reach. So this is a very good example of star hopping, which I'll be showing to you live when I go for my simulation. Now, before I proceed further, there is something you have to prepare, some preparations you have to make for the night session that I'm showing the slide. First of all, you have to decide on the time of a night session. Let's say you can decide at 9 o'clock tonight. From 9 to 10 is the time when you're going to see the night sky. I'm not sure. In Delhi, it is totally overcast. Not overcast, it's totally hazy. So we cannot see anything much here. But other parts of the country, if you are able to see the night sky, you should go and choose a time and prepare yourself for the particular time of viewing. Before that, get your orientation right. Like I told you, identify basic direction, know where the north is. That you can do before the session itself. Open your mobile, look for a compass, know where the north is. Once you face north, you know east is your right, south is to your back, behind, and west is your west. Once you know this, west is your left. Once you know this much, it will be very easy for you to go out, start looking at a diagram, and start looking at objects in the sky. Also, you have to familiarize yourself with the night sky for the time of your viewing. That means now itself you can see at 9 o'clock on the chart. You can see at 9 o'clock what are you going to see. Look at all the objects, identify the brightest objects, the bright magnitude objects in that. Let's say 7 or 10 or 8, whatever number of stars, important planets. Note them down in a notebook, and you go out with the aim of identifying those things actually in the sky. You can take a printout or you can take a screenshot, which I'll tell you how on your mobile phone. Go out and start seeing things as they are on the chart. Now study this night chart very carefully and choose the objects to view and identify. Mobile app, I've already told you, you can download Sky Map right now, which will come handy once you go out. Also, you would like to choose a spot from where to do your night session from, because the biggest enemy which you're going to face is the street lights and the light from other buildings and houses, which will directly affect your night vision. Now, night vision takes some time to adapt. You will take around 10 to 15 minutes before you start actually looking at picking up stars and planets in the sky. You just go from the brightly lit room outside and just look at the sky. You won't be able to see anything. So this needs some kind of preparation. So if you start a session at 9 o'clock, maybe by 9:10, 9:15, your eyes will adapt well to the night sky, and you will start seeing things in the sky. Keep a red flashlight and the chart which I told you handy. If you don't have a red flashlight, you can put some cellophane tape on the mobile phone, which is now a multi-tool. It will also show you the sky chart. It will also act as a torch for you, and it will show you other things also. So mobile is pretty useful tool here. Just keep some kind of cellophane or something which you can put on the backside, so that it can give you red light. Mobile should be fully charged. You can put in a charge right now, because you will prepare everything. You go out and mobile will not. Now battery will just die, and the session comes to an end. Binoculars, if you have with you, you can use. But my suggestion would be that if you not started with the stargazing as of now, first you just remain confined. First you just use your naked eyes for the night viewing. It's very good if you can put a chair or a recliner outside, because after some time you'll find that after 2 or 3 minutes of viewing on top, your neck will start straining, and it's the first problem which people face after you start with the hobby of stargazing. Now you have to perpetually look up, and it will give a lot of strain to your neck. So it's better if you can put a chair like this, or you can put a recliner on which you can recline back, just focus in the sky, gaze for some time, and suddenly you see that everything will start appearing in front of your eyes like you've never seen them before. And last but not the least, keep a mosquito repellent ready, because many stargazing sessions, when I take the classes for beginners, I've been told that the biggest problem is the mosquitoes, because if your head is not still and you are not at peace, the session will not proceed. There's something which you have to keep in mind. You can always again note down the things which are written on the slide here, and once you go out, you have to be prepared with all these aspects. Now after this, I'll go to the website which I told you, Sky and Telescope. I click on the link here. Okay. So this is the website which I told you, which is great for you to start your sessions. Now, the first page you can peruse in your own time. It gives you a lot of stuff to see. What I am going to go to is this page called Tools. Now, in the tools, I find some astronomical tools. First is the Jupiter Almanac, which basically tells you the position of the moons of the Jupiter and the position of a great red spot, where they're going to be. This will be useful to you if you have a pair of binoculars, because the naked eye you can't see the moons. But if you've got a good pair of binoculars, a very basic pair also, and it's if you can hold it steady, you should be able to see the four moons of Jupiter, even with a basic binocular. The tool which I'm going to go to right now is interactive sky chart. So once I click on the link, I reach this particular page. Again, click on this. So I am brought to this particular window. Now, if you see carefully, on the left side of the window, there's some data you have to feed. So here, first in the location, which can be taken up automatically if you have the which can be picked up automatically, or you can also manually enter the lat long here. In this particular window, I have already fed the data for Delhi, and if you come here, the time date is 8 November, and the time which I set is 9 o'clock. Like I told you, we are setting this observation for night time at 9 o'clock. So after you see this window, you'll find a printer icon on the right side. Go ahead, go to the printer and click it. Now what you see is a sky chart here. Now this sky chart, if you see, is location is set for New Delhi here. The time is 2100 hours on 8th November. Now this is the chart which is going to guide you in the sky. Now you can take a printout of this as a PDF document, and thereafter you can save it on the mobile. So once you put it on the mobile, you can zoom it, you can go to whichever part you want, and you can start using the diagram straight away. Now, how to use the chart? I just take some time on this. You see, when you see the rim of the chart here, you'll find something written here: facing south, facing southwest, then facing southeast, and so on. What it primarily means is that if you have your mobile in your hand, and you're seeing, let's say, facing south like this, and you're holding it straight, you would see everything which you'll see when you actually go out and look to the south. That means you would see, let's say, Mars somewhere here, which is pretty high in the sky, when you're facing south. Now, if you have to face some other direction, let's say you have to face north, that means I have to turn back. Like in my case, I know right now I'm facing south. My main door entry is facing south. If I have to face north, I have to turn back. So when I turn back, I'll turn the mobile in my hand like this. So this facing north actually becomes straight for me. The diagram becomes inverted, and I'm reading facing north upside down, the straight up. So when I read facing north straight up, I would find the constellations and the stars which are towards the north. For example, here I will find Cassiopeia at 9 o'clock on top. I see the pole star which is here, and I see various other stars which are due north. Similarly, if I face east, which is somewhere here, I would find the Orion constellation just rising. If I don't have any obstructions in the towards the east, I'll find Orion, which is just coming out of east, and it will be moving up and moving toward westwards during the course of the night. So this particular screen I've come to just to tell you how to get the star chart, or the printout of that, or maybe a screenshot which you're actually going to use. So the process is simple. Like I told you, go to the Sky and Telescope website, go to Tools, go to Interactive Sky Chart, feed in your lat long where you're staying. That lat long, by the way, you can find out. Let's say you're in Bangalore, you can always go to internet and say, give me my lat long. It will give you a lat long. Feed that lat long there. Choose the time at 9 o'clock or 10 o'clock if you want. You can choose any time, and then it will give you straight away a star chart sky chart which you can start using for the night observation. Okay. Now, after this, I go to simulation for which I'm going to use another app, which is Stellarium.
Um, Captain Anil, there is a request to explain how to get the position right again.
Okay, ma'am. The position in
Uh,
the you're talking about
Maybe
position.
the position, the location where one is. I think that is what he
Okay,
may be.
okay, okay.
Also, to all the viewers, this will be there on YouTube, and you could also look it up again and again.
So
Just, just
I'll just go over
please
this,
go
ma'am.
ahead. Yeah.
Okay, so now let's say I go to sky and telescope. I go to tools. Okay, so in the tools, I go to interactive sky chart, which is here. I come to this particular page. I again click on the sky chart here. Now let's say I do not know the location of Delhi. I just go there and I'll say let long of, or let's say Bangalore for that matter. Bangalore, or let's say Whitefield, the area in Bangalore. So I find straight away lat long here, right? So this particular lat long I pick up and I feed. I go say enter manually and feed a lat long here. Only thing you have to take care of is this is in degree, minute, and second, degree and minute format. What you're getting here is basically the decimal place. So what you have to do is you have to multiply it with 60 and you get the actual minute. Or you can say simply you can say lat long of Whitefield in B sorry BMS format. So DMS is basically degree, minute, and second. So you find the DMS lat here, which is 1259, and DMS long, which is 7744. So I go here, I say 1259, and I say 7744. So once I do this and say OK, you'll find the position changing. Now it is showing the lat long of Bangalore. Now let's say I want to do it at 10 o'clock. So I go here, I choose 22 hours and I submit. The moment I do submit, the position has changed. Now somebody in Bangalore, when you come here and you face south, you would see the window on the left side here is actually seeing the zoomed view of what you're going to see. So you will find, let's say, looking at south as you start looking up, and this is at the horizon. So as I go up, this is towards the zenith on top. I would be able to see Mars, but this green thing which you're seeing is not entering Mars. Mars is not entering the window. That means I would not be able to see Mars when I'm facing south. So I'll turn. Yeah, so actually you would be able to. Actually, Mars is totally at zenith. So you have to actually crane your neck and look right on top to see Mars at Bangalore at 10 o'clock. So thereafter, having done this, now I want this tool to be used on my mobile phone or as a printout. So I go to print thing here, the print icon here, and I'll get a printout here. This printout is nothing but a PDF document which I can take to my or take on a mobile phone and start using it the way I explained to you earlier. So I hope I'm clear. So ma'am, I can proceed ahead.
Yeah, yes, yes, please. Yes, yes, please go ahead.
Okay, so now I have come to another app, which is Stellarium, which I told you will show you a view as if you're seeing a planetarium. So if you see carefully, what you're seeing in this app right now is same view which I shown you at Delhi in the diagram behind. Now, if this diagram was for Delhi, you would have seen the same thing which I'm seeing live here. So here I'm going to zoom out. Zoom in, and let's say I slightly go up. So as I see here, now I would see, looking south, I'll see Mars again. Now Stellarium has got some other tools. For example, I can see what is the altitude, how high the Mars is from horizon. So if I put my cursor here and take go on top, it tells me that you would see Mars at 64 degrees no, altitude in the sky. Similarly, I can look for, let's say, Rigel, which is part of Orion. I can see if I'm looking southeast, Rigel would be, let's say, at 22 degrees 55 degrees north. And also, I'll take this opportunity to explain to you as to how the night sky or the objects in the sky move during the night. So first of all, I'll give you a small orientation of what is there in the night sky. You see now you're seeing many bright spots here, and you see some names: Kepler, Rigel. You see Uranus, you see Mars, and all those things. Now all these things are stars here, which are seen in the night sky at a particular latitude, which are already fed. It has already taken my latitude here, which is Delhi latitude. So this is what I'm going to see in the night sky when I go out at, let's say, this time is here is 22:18. So this is at 10, 15, 10:18 in the evening. I'm going to see all these things in the night sky. Now I'll just explain to you what is there in the sky to see. You see, we all know about constellations. So the entire night sky has been divided into 88 constellations. Now constellations were arbitrary figures which the ancient astronomers or people used. They made some figures in the sky. They put some stars together and they started giving a name. For example, Great Bear or Ursa Major or whatever, or any other constellation. Now, these things are actually arbitrary figures which people have drawn in the sky, and which have over the period of time it became the part of a culture, and it also now passed on to the modern school of thought, and people started recognizing them the way it was seen by the ancients earlier. But there was a problem. The entire sky was not covered. All the stars were not covered by the constellation names and the constellation which the ancients had drawn. So the International Astronomy Union, they found a solution. They said we are going to divide the entire sky into 88 equal parts, and each part and all these 88 parts were made the constellations. So now, even if you have a telescope or you have a binoculars, you look at the sky, you find any star in that particular region of the sky or space, that becomes a part of the same constellation. So I'll just explain the concept to you here. When I go here, I see something like constellation lines. Now these are, like I told you, arbitrary lines which people have drawn the sky joining the permanent stars. And when I go here, I choose the names. So now you start seeing some names appearing. We start appearing on the screen here. So if I zoom in, for example, here, let's say I would find the names like Andromeda, which is here right now, Pegasus, Pisces, Taurus, Aries, Perseus. They all are the constellations. And like I told you, if you want to see the limits, okay, these are the various, the app gives you the various things like, the images which ancients are drawn. For example, Pisces, a fish here, and, we have Triangulum here, we have the Andromeda, and we have the Orion, which is somewhere here, and so on. So we can close this. So you'll find that most of the sky, as you go up, is covered with all these constellations which have got set boundaries, and all the sky, all the stars which you see, they fall into some constellation or the other. Having seen this, this red light which you're seeing here is something which is known as ecliptic. Now, the sun, the stars, and the moon. Well, not the stars, the sun, the planets, and the moon, they follow a particular path in the sky. And since the plane of most of the planets is same as that of the sun, uh, you will find they all take the almost the same line in the sky. Now this line we call the ecliptic. And as I run the simulation, you would find that most of the all the planets as well as the sun and the moon, they'll follow the same path in the sky. Also, I want to tell you one more thing. You see, we know about the science of zodiac. We all know our sun signs, the 12 signs, which are very dear to our heart because we believe that they explain or they, portray our personality. For example, I'm a Cancerian. Somebody is a Scorpio or a Piscean. So everyone has got, a very special corner for the sun signs in the heart. Now, I just want to explain to you the sun signs are nothing but like other constellations, but those are the constellations which are falling on the line of ecliptic. That means those are constellations through which the sun seems to move during the course of a year. And the constellation in which, or the sign of the zodiac in which the sun is there right now, this particular month becomes that sun sign. For example, this month belongs to Scorpio. So right now, as you will see, sun is actually indeed in the constellation Scorpio. So Scorpio as a constellation cannot be seen in the night sky because it is under the glare of sun, and you can see all other constellations. But this becomes the principle, or this becomes the science, if you want to call it, behind the constellations. So what I'm going to do now is I'm going to quickly run the simulation here. I have an option here in which I'm going to advance the time fast. So you would see here that I have east to my left and I have west to my right. This is primarily because I'm facing south. So if I'm facing north, as you know, east is to my right. So when I'm facing south, east is to my left. Now, as I run the simulation, you would actually see, for example, Mars here and other stars. Here's the Orion, which is at 10 o'clock will be up. You will find all the things start moving towards the right, that is rising in the east and setting in the west. So here we go. So you see how Mars is now moving westwards and going to set, and we have already got the moon here, which has come up somewhere around 12 in the night. Here's the time. So 2 o'clock, and now at around 3:30, Mars is gone, is set. Venus has come up at around 4 o'clock, and followed by Mercury on the left side, and this. Now, this is a particular time which I want to explain to you. I'll slightly go back here again. So morning time, which is like, let's say at tomorrow morning at 5:35, I would be able to see Venus here. Which is just come on, which is just risen and is also the brightest star in the sky. And this, brightest star in the sky, and this is now also known as the morning star or the Lucifer. Venus, actually, ancients used to confuse Venus as two different stars because it was seen, because of proximity to sun, it was seen as a morning star or the evening star. So the evening star was known as Venus, the goddess of love and beauty, and the morning star was known as Lucifer, which actually means the bearer of the light. That means Venus was always seen coming before the sun as to bring the daylight. So it was known as the Lucifer or the bearer of the light, and followed by Venus is Mercury. Now, Mercury is a planet which can be seen by the naked eye. It's a very bright. However, because of the proximity to sun, it's very difficult to see. Now, if I go and see here, if I move the, like I'm facing now right now east south east southeast, and I'm seeing Mercury here. And if I take the altitude, so Mercury is just about 9 degrees of the horizon. It's very difficult to see. And as Mercury goes up, you will see the sun will start falling. So by this time, when Mercury is slightly risen up, we have already seen the daylight here. And everything else, all the stars, Venus will stay for some time because it is the brightest star, and also moon. You can see moon even during the afternoons. So Moon and Venus are going to stay, whereas everything else is going to be basically drowned in the sunlight. Mercury is the first star we're going to lose. So therefore, it was very difficult for us to see Mercury. If we have to actually see Mercury, we have to go to a part of the sky where the east is totally clear of any obstructions and start looking very carefully. You will have only a window of about half an hour before sunrise when you will be able to see Mercury, and thereafter it will go get lost in the glare of the sun. So as we move up, we see the sun rising. Oops, sorry, it's too fast. Yeah. So as we move up, we see the sun rising, and we see slowly daylight is coming, and all the planets, the stars, everything is getting lost. Here it is. At sunrise, everything is gone. I can see the name Venus, or Venus is gone. Moon, though sufficiently away from sun, can be seen maybe throughout the day. This is the movement of sun in the sky along the line which is known as ecliptic. And I'll keep an eye on that time here. So now we're going towards sunset. So at around 1705, sun has set, and I've started seeing the night sky again. So what you see in the night sky these days, the two prominent objects are Jupiter and Saturn, which are very close to each other and can be seen as the brightest objects in the evening sky. However, the window for which you want to see them is actually very less because they are setting very early. So let's see now. Time is now 18:20, and I'm seeing Jupiter and Saturn both in the sky. Also, Stellarium gives me a feature in which I can actually see Jupiter and Saturn the way, or any other planet for that matter, the way it will be seen through telescope. Now, when I go here, choose Jupiter, I start seeing the data of Jupiter here. Magnitude is minus 2.12. Is azimuth and altitude, basically the bearing and the altitude I'm seeing here. And if I choose this particular feature, I'm able to zoom in the Jupiter. So the moment I zoom into the Jupiter, I'm able to see the four moons of Jupiter, which are Europa, Io, Callisto, and Ganymede. So this I would call not even a. This is maybe a low power telescope view, or this can also be seen not as big, but a smaller version of this can be seen through binoculars also, like I explained to you earlier. And when I zoom in further, let's say I use my telescope, I would see Jupiter much bigger than this. The moons will disappear, and only the Jupiter surface will come in picture like this. So this particular view you must have seen, on in various magazines or online. This is how you see Jupiter on a clear night through your telescope. Similarly, if I choose Saturn here, and let's say I zoom in, this is what I'm going to see. I'm not only seeing Saturn, I'm also seeing these moons, Titan, Rhea, and so forth. I think 7 moons of Saturn can be seen through a telescope, which is being depicted in the slide here. If I go further in, I should be able to see Saturn, the rings, and the main body of the planet very clearly. There are some photographs and videos which are taken using my telescope, which I'll be showing you towards the end of the presentation. Similarly, you can see many other things in the sky, various stars, form a heart, or any other thing, whichever I want to see, you can see in the sky. So if I choose Mars here, again zoom in, I get to see Mars with the two moons, Phobos and Deimos, which actually mean the fear and the panic. These are names of the moons of Mars. So I will see Mars. This is obviously a photograph which has been taken maybe Hubble telescope or maybe the graphic. You will not see Mars as clear even through a telescope, primarily because Mars is having an atmosphere which is always full of dust. So there are dust storms which are going on Mars all the time, and they cover most of the planet's surface, and you're not able to see it very clearly, even through a telescope. But if you're lucky, on a clear night, you should be able to see a fair amount of detail on the surface of Mars. Okay, so this is how you can use Stellarium for simulating the night sky. Now I explained to you the star hopping phenomena, star hopping and stargazing, and here I'm going to explain to you as to how you can use this particular technique to look for the faint stars or the objects in the sky. The example which I'm going to take is of Uranus. In fact, I was able to spot Uranus using the same technique. Firstly, I saw it through my binoculars because see, if you see here, you can't hardly see anything else. Well, Uranus magnitude is 5.66, and like I told you, the naked eye magnitude is 6.4, or somewhere it's 6.6 to 6.4. So Uranus is very difficult to be seen through a naked eye unless you go to very clear skies. But you can see it through a, let's say, binoculars. But however, if you look at a binoculars, for example, now I have a binocular which has got a field of 6.8 degrees. So what I do is, let's say, if I take this particular tool here, okay, I can't see anything. So this is around 3.2 degrees. So this, if I draw a circle here of 3.2 degrees, let's say this is what I'm going to see into the field of my binoculars. Now, when I see in the field of my binoculars, I don't actually get to see anything in this. There are no stars. I mean, even if there are stars, I don't know. There may be thousands of stars close to Uranus. I don't have any means of knowing that what I'm seeing indeed is Uranus. But this can be confirmed only through a procedure which I mentioned to you, or the technique which I mentioned to you, which is star hopping. So what I do in star hopping is, now let's say in this particular case, I'll go to Mars. Okay, I choose Mars as my peg because Mars is going to be seen very clearly on any night. Let's say I slightly zoom in. So I will go to Mars and start my route to Jupiter from here. Now, if I see around Mars, I see many stars. I see something here. Now, when I click on this, one second. Okay, I'm not able to click onto the. This is why I'm not. Some problem. I can't use the mouse. Anyway, so there's some problem with the. Okay, maybe because of this. Yeah, now I can see it. Okay. So when I click on Mars, I see many other stars close to it. So let's say this is 71 Pisces, or epsilon, which I can see magnitude 4.25. I see something here, which is magnitude 3.8, which is better than the previous one. I see Hummel, magnitude 2, Sheraton, 2.6. So all these stars are going to be visual to me. For example, let's say I pick up a star which is here, which is 4.25. If this star is visual to me with the naked eye, I can be very sure that anything which is less than 4.25 is going to be seen with the naked eye. So what I'll do is, I'll, let's say, use my binoculars. I look at Mars. So let's say this is a field of view of my binoculars. I draw one circle here. So I am finding now Mars and these two stars. So let's say this star which I'm going to find is magnitude 6. I might see it in my binoculars. So after seeing this star, I now move down. Using my binoculars, I draw a second circle in which the common star is there. So let's say I draw circle number 2. Now I know about this particular star which is here already. With relation to the star, I identify 1, 2, 3, 4 more stars. So I know this particular star I'm looking at is indeed HIP 5824. So I know the name of the star. I go further down in the overlapping field of my binoculars, one more circle. Find 3 more stars here. Choose it. I find 3 stars which are close to each other, which I know what you are looking at. And so what? While going with the same technique, I keep drawing circles which are having the stars in a common field. Keep going down. Now let's say I come to a situation wherein I can't see any stars common. All I have to do is I have to draw one line, let's say from a particular star which I identified here towards south, and I start looking for the brightest star which I'm going to see. So this is another technique I use for star hopping. The moment I do that, I find this bright star here, and I find in fact two stars which are close by. So I know after this when I move down, the star which I'm going to look at now, I'm looking at is this particular star which is 65 Cetus. Okay, now after this, I draw the circle which is the field of view of my binoculars somewhere here. So many new stars become visual. Let's say I pick up this star now, draw a common circle here. So moment I do it, I come very close to Uranus. So what I've done now is moving from circle 1, 2, 3, 4, identifying all the stars, and I can choose peg stars here which are common. For example, I can choose one of these two, then I can choose this one. I can choose these two stars here, for example, which is this HIP 7243 alpha. I pick up this star, next common star, next common star. After this, nothing prominently visual. I just jump and come to this particular star, which is Alka F or 65 Cetus. From there, find a common star here, which is 10776. Draw another circle, come to this particular star, which is 73 Cetus. Now, or Al Jidma. Once I come here, now I know Uranus is very close. What I'll do is, let's say, if I go up now, the circles of no use, I have already done the job. So I've identified a star here, which is going to take me to Uranus. Let's say the star is here. And I can remove all the circles now because I've done my job. Now, reaching here, now I have to look up, go through this particular field here, which are the stars, which are something looking like an inverted C. So this I cannot miss. So I know this star, I have seen inverted C. As I move up, you will find I am not going to encounter anything else here, which is as bright as Uranus. Maybe I'll encounter something which is this particular star, but this is magnitude 9. It's not as bright. I'll find something which is 5.66. Now, when I move up, the brightest star which I'm going to see in this particular field is Uranus. Other way of doing it is maybe I can draw another circle, which is something like this, having some common stars here, depending on field of view of my binocular. And thereafter, I will come to this particular star and slightly, northwest of it, or let's say if I use the clock code, maybe 11 o'clock from here, I should be able to reach Uranus. So once I reach Uranus, using the technique which I told you, you don't have any doubt, but you know, but we are very sure that what you're seeing is Uranus indeed. Now, this particular thing cannot be done if you go straight away to that part of sky, put your binoculars here, and try to identify. Now, like I said, using the same technique, I was able to find Uranus and Neptune both onto my binoculars. However, in the binoculars again, Uranus is seen only as a small dot, which I'm seeing it here. There's no means of confirming whether it's actually a planet. The only way you can confirm it is if you look through your telescope, and that's what I've done. So if I take you to my presentation again, what the dot you're seeing here is indeed Uranus. So the video you saw was taken by me in the month of August, in which I had to spend about good about 3 to 4 hours I was outside, uh, retracing my steps first through visual naked eye. Thereafter, I use my binoculars to identify the peg stars, starting from Mars, till Uranus, and then I was able to move my telescope manually from Mars to all these stars, identifying them on the way, and finally reaching Uranus. The moment I reached Uranus, though the video was not very clear, but I could see a very clear blue planet, pristine blue colors. And what was to confirm that it was Uranus was that it was indeed moving. That means if I put my telescope towards the star, it will not move the way it was moving in the video. The movement which was shown in the video was natural. It was actually Uranus which was moving across my field of view of the telescope. All other stars in the backdrop was steady, and only this particular thing was moving. And again, if you see the video, in fact, I picked up two moons, not one, and both the moons were seen to move along with the Uranus. And since there was no other planet or satellite or anything in that part of the sky, it was very clear that what I had picked up was actually Uranus. And of course, the color and everything was there to as a proof. And similar thing can be used for Neptune, which is again very very dim. It cannot be seen through even binoculars. But if you know the peg stars, you should be able to pick up Neptune, which I have actually done with the help of my manual telescope. Now from this, I will move into the next section, which is the equipment. Now, as I mentioned earlier, the smartphone is a very important tool for amateur astronomy. And you have to use the same phone which I've already got. You don't have to go for any special kind. The smartphone camera, the software, the apps, as well as the torch which is there, is more than enough to see you through for most of the sessions of stargazing. After you see after you are comfortable with the naked eye, you can go for binoculars, and later on, when you feel the time has come for you to invest in a telescope, that's the time you go and buy a telescope. And as you progress in the hobby, you can go for the dedicated planetary cameras, which will give you beautiful photographs of the planets, and maybe a DSLR, which can be used along with your telescope. Now, smartphone, as I told you, got astronomy apps, flashlight, and astrophotography. And what I want to tell you here is that astronomy is not as much about the equipment as it is about a skill. Now, towards the end of the presentation, I will show you some photographs and videos which I have been able to take, which people have not been able to manage, even with a dedicated camera or even DSLR. It's primarily because I have been working, trying to find out the ways and means to get the best photographs onto my smartphone. And this 15,000 rupees phone, which is very average phone, has been is being able to give me is has been able to give me some very good photographs and videos, which I have not been able to get even on very expensive cameras and phones. So it's only your way of understanding your equipment and spending time with it and getting better at the skill. Now with binoculars, the binoculars reveal much more than naked eye. A number of stars which you can see through binoculars increase manifold. So, like I said, planet Uranus, even the galaxy Andromeda is the nearest galaxy which I have, and the only one other than the clouds which we can see, Magellanic clouds which you can see in the south. I think this is the only galaxy which we can see in the northern hemisphere. Then you can see star clusters, many messier objects, details of lunar surface, everything you can see through binoculars. Also, you can see the moons of the Jupiter, as I mentioned earlier. And if the binoculars, you actually hold them very steady, you should be able to see the elliptical shape of Saturn, if not the rings. Now, when you're choosing binoculars for astronomy, you have to understand that you have to choose the bigger front lenses. Here, binoculars have got lenses behind the eyepieces and the front lenses. So the minimum diameter of the front lenses should be around 50 millimeter. If you buy 60, it's much better. Now, there 50 to 60 diameter of the front lenses are considered ideal for astronomy. Now, the first figure here, like I have written 750 or 1050 are good choices for beginners. The 7 and 10 are basically telling you the magnification. So this binocular, which is 750, would magnify the image 7 times, and the one which is here will magnify the image at 10 times. But as the image is magnified, your field of view is going to reduce. So if you're looking at star clusters or you're looking at the open sky in which you want to see too many, stars together, or let's say you want to see a big constellation, you have to use a binocular which is having less magnification, or you have to use a naked eye. Like I told you, what naked eye can show you, binoculars and telescope cannot. If you want to actually enjoy looking at, let's say, a constellation, you want to see this whole form of Scorpio, or for that matter, Ursa Major, you will not be able to do it with the help of binoculars or telescope. You have to actually look at with a naked eye into the sky and trace out all those constellations. Also, as the magnification goes up, like 7 to you go to 10, there are binoculars which are dedicated astronomy binoculars, magnification of 12 into 60, or let's say there are 15 into 75. All these bigger binoculars, as you go up in the magnification, the weight of the binocular is going to increase. So, for example, the 7 into 50 will be somewhere around, let's say, 300 grams to 400 grams, and 10 and 50 will be slightly more. So, when you are looking at sky with the binoculars, your neck is already strained and craned, and your hand is not steady. So if the binoculars are heavy, you're going to shake, and if you're going to shake, all the viewing pleasure is going to go off. Now you look at the moon, and if the picture is shaking, you will not be able to enjoy the view at all. And for that, you have to use a tripod maybe. So when you go for heavier binoculars, let's say even for 1050, you would have to use a tripod to keep the binocular steady. And even if with the 750 also you can use a tripod, the attachment which comes, and if you use 750 also on a tripod, it will give you much better and clear image. Now, after binoculars, we go to telescope. So telescopes are ideal for solar, lunar, and planetary viewing, and also looking at the deep space objects, or DSO, meteors, galaxies, star clusters, and nebula. So all those things which are beyond, our immediate, let's say, solar system, they are best seen through telescopes. No, but telescope cannot replace the naked eye and the binocular observation. If you want a bigger field of view, you have to go for the binocular or naked eye only. Now, naked eye scan and the binocular observations, followed by the telescope viewing, are key to finding many objects, like the example which I gave you of Uranus and Neptune, and even Andromeda galaxy. So you have to first look at the part of sky through naked eye. Then you have to find the peg stars with the help of binoculars. And only when you remember the peg stars and draw a chart, onto your notepad, then you take the telescope there and start tracing the particular path to reach the target. Now, quickly go over the types of telescopes. So there are basically two kinds, I would say, which is first is the Galilean telescope, which has got lenses into it. So you have the lens in front, and you have the lens behind, through which you look at the picture image ahead. Now this is called a refractive telescope. Now here the limitation is, as the size of telescope goes up, becomes bigger, the lenses become very heavy, and it is slightly untenable to use. So you go for a second type, which is called Newtonian refractive telescope. Now this telescope, instead of lenses, uses mirrors. So you have a primary mirror which is at the base of telescope, which is somewhere here, which is seen here in the image, and you have a secondary mirror which is somewhere here at 45-degree angle, which is shown here. So the light which passes into the telescope hits the primary mirror, which is a concave mirror. It comes to the secondary mirror and comes out through the eyepiece, which is shown here. So the light comes from top, goes down, hits the primary mirror, comes up again, and is seen out through a telescope here. Now, this particular telescope is also a type of refractive telescope only, but here the only difference is that instead of seeing from top like here, you will see it from behind itself. So your viewing tube is behind the telescope itself. So the light which goes, hits the primary, hits the secondary, which is a convex mirror here, again comes back, and there's a gap in the primary mirror through which you are able to see it. So this actually reduces the size of the telescope while keeping the focal length same. But also the cost of telescope goes up because of this advanced technology. Now, what is most important in telescope is the telescope base. Now, there are three types of mounts or bases which are available. The first one is the equatorial mount. Now, this particular mount is also called altitude mount, altitude azimuth mount. This particular mount, once you set it, start moving on its own and start cancelling the rotation of the Earth. Now, a manual telescope, which is a Dobsonian telescope here, like I've shown the example of the video which I've taken. Once the Dobsonian telescope is set, it is looking at, let's say, a particular object. After that, as the object moves out of field of view, the lock is broken and the object goes out. So the Dobsonian telescope is looking only one particular part of the sky, and it is not catering for the cancelling the rotation of Earth. An equatorial mount is doing that. It is actually moving the telescope opposite to the motion of the Earth, and it is actually locking on to a particular scope, a particular object in the sky. Then the third type of mount we have is a go-to or a motorized mount. Now, go-to mount is again tracking mount, but here you got a small robot or a computer here. All you have to do is you just feed in the object you want to see. You see, okay, you feed in this window here, Jupiter, and the telescope automatically will slew towards Jupiter and start showing you the image of Jupiter into the eyepiece. So this particular mount is very good if you want to go for a deep space deep sky photography, or you don't want to use the manual mount. But as you move forward, I'll explain to you that actually for a beginner, the mount and the telescope which are best is the center one, which is the Dobsonian mount. So this particular mount is the most steady, and this is something which needs least of the care, and is something which is going to last you for most of your life. Now this is totally mechanical. There is no moving parts. There is no battery. There's nothing involved in this, and this is very very. If you see the shape of the mount, it has got a huge base down below, and it is very sturdy. So this particular telescope actually gives you the best vision, best views. Also, best part of Dobsonian is that it can actually take very large and huge size telescopes. On a equatorial mount like this, or maybe on a tripod like this, you will not be able to mount, let's say, a big telescope with a aperture which is more than, let's say, 8 to 10 inches. And when it comes to telescopes, actually aperture is the key. Rest everything is secondary. It is how much light you want to collect that actually matters, which I'm going to explain in the next slide. So first and foremost, the first buying consideration for a beginner is the budget. Now, as I said, the least expensive telescope in this is the Dobsonian telescope. Now, this would be, let's say, about double the cost, and this will be maybe 2 or 3 times the cost of Dobsonian telescope. But at the same time, the most stable, the most redundant, and the most usable telescope, most recommended for a beginner, is Dobsonian. So this will fit in the budget very beautifully. I spoke about aperture. Now, bigger the aperture, more is the light intake of telescope, and more is the magnification. There's a rule which says actually the magnification depends upon two things. One is the focal length of the telescope and the focal length of the eyepiece. Now, as I use a different eyepiece, using the same eyepiece on different telescopes, I can keep magnifying things. But there is a limit to which you can magnify. Now, let's say, since I told you it's a ratio of the focal length of telescope and focal length of the eyepiece. If the focal length of the eyepiece goes down, my magnification keep going up. But there's a practical limit, and the limit also depends upon the diameter or the aperture. So, in a nutshell, without going into any technicalities, bigger the aperture, the more you're going to see, more the magnification, and more the resolution. Next is, of course, the mount. I told you Dobsonian is the most stable. And if you go for a normal Dobsonian mount, you compare it with a low and equatorial mount. Like, for example, what I'm trying to say here is, let's say this particular telescope is costing 50,000 to you. You buy a equatorial mount for 50,000, which will be really low end and which will not be stable at all. So if you want to buy a good equatorial mount, you have to spend a lot of money. In the same budget as Dobsonian, you will not be able to buy a good equatorial mount. So if you go for equatorial mount, which is cheap, in the same budget, your image is going to be not steady at all, and it will be unsatisfactory. So you please go for a mount which is sturdy and which is the best value for money. Also, there's a weight limitation. You see, as the telescope's aperture goes big, the overall size of telescope actually goes big, and it actually becomes very bulky. So, like, I have a telescope which is now 10 inches aperture. It is around 4.5 feet is the tube, and it is around, say, 30 kgs. The base and the telescope separately is 15 plus 10, 25 kgs. Now, this is a very heavy telescope. If you have to move it from one place to other place, or you have to set it up every day outside your house. So maybe a child who's trying to use the telescope will not be able to do it on his own. he would need a smaller aperture telescope, which is easy to handle. And last but not the least, you can buy any telescope. It is the quality of the optics which matters. You buy a small telescope, but good quality of eyepieces and optics, it will give you much better results than expensive telescope, but in which you have all the zinc bang, you have all the go-to properties, you have a robot computer, but if the optics is not good, ultimately what you're going to see is the image, which will depend on the last factor, which is quality of optics. So if you have a Dobsonian mount with good quality optics, that is the best telescope I think a beginner can buy. So, my experience, the source of buying these days after buying a telescope is slightly difficult in India because most of the telescopes are actually built in China. So most of the scopes which you buy even from abroad, the Chinese companies were making it. Orion was one, Celestron, and there are many other companies who are making, which have got their base in China. Now with that particular stream of telescopes, getting closed, the options are getting limited. But then there are options like the company called GSO, Gongshang Opticals, which is from Taiwan. It has got a distributor in India. I can share the whosoever interested. I can share my address and number later on. So I can tell you about vendors which are not putting the presentation here. So there are options available, and you can actually use these options to buy telescopes. Source of buying should be actually a distributor, some known person in India. Do not go for telescopes which are being sold online. The two reasons: first, they will be very expensive, and secondly, you're not sure of quality. It has got very sensitive parts, and if something goes wrong, the collimation or the mirrors, the alignment goes wrong, you would not be able to use the telescope any further, and it will be a big hurdle for you. I have got a 10-inch GSO star tracker, and my viewing experience with the telescope for the last 6 years has been wonderful. I have also been able to connect my webcam and my mobile as do-it-yourself projects, and I've been able to, without even going for an expensive planetary camera or DSLR, I've been able to take some good quality photographs and videos from there from the my telescope, which I'll be sharing with you soon after this. I told you about a limitation of a platform of a Dobsonian mount that it is not able to auto track. But this is one limitation which can also be made good with the help of something known as equatorial platform. This is something which I bought recently. This is like a platform which also does the same job which a AutoZ mount or go to mount does. It is basically moving in azimuth and in elevation in such a manner that my Dobsonian telescope gets the tracking facility and very accurate tracking facility for about 1 hour. Now you don't need more than that, even if you want to go for the photography. So a normal telescope, which is a manual telescope, can also be made a tracking telescope with some third-party equipment like the equatorial mount platform, which I just mentioned. And then of course you can go for planetary cameras and DSLR, which I am now think of graduating later. As of now, everything which I've done is with the help of a simple mobile phone. So here is my telescope, which is 10 inches aperture GSO. I have modified a webcam myself, which I am using on the eyepiece to record automatic videos. And this is a small appendage I'm showing here. Is nothing but a bracket. And this particular thing you see here is the eyepiece of the telescope. So this particular bracket, when put on the eyepiece, m- uh, gives me the capability of putting a mobile here. Once I put my mobile, which is shown in the picture also here, I'm able to record the videos and the photographs with the help of my mobile phone itself. Now with this, I'll show you some videos which I've shot. Now, this is the video of Jupiter, which I shot with the help of my mobile phone. Now, mind you, you would not see this bigger picture, this bigger image of Jupiter when you're seeing through the eyepiece. This is the image which has been magnified with the help of using the camera or the mobile. This is a video of Saturn which I've taken. This is a close-up of the moon. Basically, it's a zoom. I zoomed onto the moon surface and shot a small video with the help of mobile. So you can see the fair amount of detail can be is visual on the mobile on the surface. This zoom which I saw later on, this was the zoom of my mobile phone. So as you can see, a lot of detail of on the surface of moon. The craters and other features can be seen. The seas, everything can be seen with the help of normal mobile phone captured video. This particular video is of the shadow of Jupiter's moon Europa onto its surface. So by zooming it on the surface, this was a time when the moon was moving past Jupiter. So this video was shot over a period of around 3 to 4 hours, and thereafter it was made a kind of timeless movie, and you can see the movement of the moon over surface of Jupiter. So towards the end of the video, you can see the moon actually coming out, and the shadows following. This particular thing which you see is the shadow of the Jupiter of the moon, and here somewhere in the towards the end, you'll find actually the moon coming out of Jupiter. Now using some software which is available online for free, which is basically PIPP, auto staggered and Rastex, I am able to actually make get some nice images of Jupiter and Saturn, or any other planet for the matter. Now, for example, this particular video which I just shown you of Jupiter and of Saturn, when this is moved to the software which I mentioned here, gives me the images like this. Now, this particular image, if you see, is a zoomed in image of Jupiter along with the moon and the shadow here. And what you're seeing here is the image of Saturn, which has been taken out of this video. A magnified image shown here, Jupiter, the moon, and the shadow. And here in this image, I've been able to capture some of the detail on the planet's surface along with three moons, which can be seen here. Some more images of Saturn. This is the image of moon which I've taken with the help of my telescope. This is a sunspot which I have captured. Now, telescope can also be used during the daytime. So I have captured a sunspot here, which can be seen in the image here. Now, one point which I want to make very clear here is that looking at the sun directly or through your equipment without a filter is very dangerous and should not be attempted. We also know about solar eclipses. So anytime looking at the sun directly with your eyes is prone to injury, and it can damage your retina for good. So never and never you should look at the sun directly without a filter. The image which I've taken here is actually through a solar filter which I've used on top of my telescope. Whereas moon has got no problem. Whether it's a lunar eclipse or whether it's the moon surface, you can always look at moon directly through the naked eye, through a telescope, or through the binoculars. But for sun, you have to use an appropriate filter at all times, and never attempt to look at sun during the normal times or during solar eclipse through naked eyes. Now, with this, I come to the end of the presentation. If there are any questions, I would request Dr. Rathnasree to coordinate and can put up the questions to me. Thank you. And can put up the questions to me. Thank you.
Possibilities of high-end amateur astronomy with very simple equipment. So there was one. There have been many questions, and I've been answering them on the run. But there was one question about equatorial mount. If you will come to the studio window, you will see. So the question is, how does equatorial mount telescope move with Earth's rotation? That's the question. And I also
Okay.
wanted to put in some inputs about it, but first I will give you the question. How does equatorial mount telescope move with Earth's rotation was one question. So
So,
you
ma'am,
you go ahead and I will.
I stop sharing my screen, ma'am, and come to the studio
Yeah,
window.
you can. Yeah. You come to the studio window. The question is there.
Okay. So question is, how does the equatorial mount telescope moves with Earth's rotation? See, basically what you're doing is you are basically cancelling the rotation of Earth. So for example, if I have to look at a particular object in the sky, I know that with the rotation of Earth, the rate of motion of the particular object I know. So using the equatorial mount, which is basically nothing but moving the telescope along with the particular object based on the latitude at which you are in. It is basically keeping it locked there. It's a very simple actually phenomena which can be. I can share the link for that, which can be gone through. Primarily, what you're doing is cancelling the Earth's rotation and keeping the telescope locked onto the object you're seeing.
Yeah, and I just wanted to add in this that basically you are pointing towards the pole star or the north celestial pole, right? And then all diurnal motions, they are east west kind of, and
Correct.
therefore when you are doing this, just one motion is allowing you to track an object. If you have the dog or an altas kind of any other mounting system, you'll have to move it a little this way, a little that way, a little this, keep moving it to track the object. Whereas with an equatorial you move it. And if you are near Uti, or if you go there anytime, go to the Uti radio telescope. The Uti radio telescope, when it was built, it was using this fact that you want the mounting to be pointing towards the pole star. So there was a hill. Professor Govind Swarup, father of radio astronomy in India, he found that there is this hill which has roughly the same kind of angle as the latitude of the location, which is what you need to do the polar alignment. And so the telescope was built using that. And so it has this antennae which can, just by moving in one direction, track an object as it is going east to west. So that's, I just thought that that'll be something. But your entire discussion, Captain Anil, it was just wonderful. I mean, you start with the very beginnings, and then you come to things which amateurs can do with the very simplest of equipment. And this will be a very good resource, and I'm just telling all the viewers, this will be available on YouTube, so go back to it again and again, and you can use that. There were a number of questions earlier, but I was answering them in text. But now there are some more questions which are coming up. So Nagarajan, any method to find the direction of north or south using moon when we look with our naked eyes, please? That's a little more
So, ma'am, you
complex
would
issue.
like to take it on?
A little bit, but I think we should do a full session on something like this, because when we are
Correct.
doing celestial navigation, the kind of the direction in the sky that you're seeing, and the line of the what is this, the dark side of the moon and the bright side of the moon, they are very in a sense they are a little bit location dependent.
Correct.
And so
Correct.
using this, you can actually do it, but this is a little complicated. It would be very nice if we do a full session celestial navigation related, where such aspects could be tackled.
You can do that, ma'am. No,
we,
so
we, we,
what
we,
and what you were
huh?
actually pointing out was a differentiator, the line which actually divides the lit part of moon and the non-lit part of moon. Now, if you draw a line from there which is perpendicular to this particular line, it actually points to the
Yeah,
direction of the
that
sun.
goes to the,
That's
yeah,
one
that
broad way
that
of
goes towards
looking
the
at it.
sun. Yeah. Yeah. Thanks. Actually, we could have had done this very, I mean, at least that simple thing I should have also mentioned. I
Not a
just thought
problem.
that the mathematics involved in it and all that, there is so much exhilarating stuff to do with this moon demarcation. But just that point is very nice that it was made. And now somebody is asking what all constellations are visible in Vishakhapatnam. Well, everything that you see everywhere. You want to take this, Anil ji?
Ma'am, whichever way. Okay, so basically, constellations are not dependent that much on your location in the country, let's say, but they are actually dependent on the hemisphere you're in. So when you're in the, let's say, northern hemispheres, you will see a set of constellations which are universal. You would see them from anywhere. The only thing is, as you go further up north, you start seeing certain constellations which are more clear, way much higher up in the sky. So that's the only difference. For example, let's say, to give you a simple example, let's say there's Earth, and all around the Earth are the stars. So there's a equator, our equator. There are some constellations there. So if I'm sitting on the equator, I would be able to see the constellation right up on top of my head. Now, as I keep moving towards the pole, all the constellations will start going down and start appearing close to the horizon. But anywhere in between, when I'm there, I should be able to see almost everything which can be seen in the northern hemisphere, and that applies to Visakhapatnam as well. So other thing is, the signs of zodiac, which are the constellations which people are interested in. So basically, you can see the signs of zodiac almost, other than the signs which are there, which are occupied by the sun. That means your sun sign. For example, Scorpio this time. Maybe Scorpio, one zodiac sign this side or that side. Other than that, almost all the signs of zodiac, which are again constellations, can be seen almost on any night. Or the course of night, you'll see, if you go to Stellarium and run the simulation, you would be able to see those signs appearing in front of you and moving across the ecliptic.
Yeah, this question was related, so that's why I put this also. And the question is, how does the sun move with the ecliptic line? It moves along the ecliptic line, and does it change its location? Yeah, it keeps moving to a different zodiacal constellation each month, as was discussed in the session. Now, when the sun shines on the constellation, it is the time the constellation is there. Yeah, I think what you're trying to ask about is that when the sun is in that constellation, we'll not see that constellation. One
Correct,
here
ma'am.
and there, if you have dark skies, but in the city kind of skies, two constellations here and two constellations there, we may not see, and so the rest of them will see.
So, ma'am, just to add to this, the way the question was put, you see, constellations are the basically the set of stars which are far, far, far away. So, let's say I'm seeing, if I am Earth and constellations are here, Sun is somewhere here. So, constellations are the far off stars which are moving. Whereas, as I go around the Sun, I see Sun in the backdrop of different stars. So that is the way of one way of saying that the sun is moving through various constellations, whereas the sun and the stars are fixed. It is the Earth which is moving. So let's say if I am right now here, and this is sun and this is Earth. So when I move, I am seeing sun right in front of me. So when I move this side, I'm seeing a different set of stars. So as the Earth is going around, it is seeing the sun in the backdrop of different stars. And relative motion is that sun is moving through different constellations. So
This
it is not the
question is,
sunlight which is it is not the sunlight which is shining on the constellations. It is basically sun is in the having the constellation in the backdrop, and since the sun is in front, I am not able to see the constellations.
the question says, how can Orion be used to find out true north for observing southern hemisphere? Generally, in the southern hemisphere, Orion you could use, it's a more southerly one. You could do star hopping and find where you don't have a star in the southern pole, but the constellation near it, which is that's the Southern Cross,
Uh,
right? Southern Cross. Yeah, you
yes,
wanted
no,
to.
no. Basically, the question is slightly different. What he is saying is, how can the constellation of Orion can be used to find the true north? So, answer is very simple. If you see the orientation of Orion, the top two star, Betelgeuse and
Yeah,
Bellatrix,
that's right.
and the two
That's
stars
right.
below, Rigel and Saiph. If you run this line through and
Yeah,
through Orion,
yeah,
if you run the line through and through Orion, it is straight away points to north. So, Orion is a constellation which is actually looking towards north. So if you run
yeah.
a line through
Lovely.
Ryan, actually, the question which Madam was trying to answer was, We have North Star, which is giving me true north. But if you go to southern hemisphere, we do not have any star there. We have something known as the Southern Cross, which is a constellation which is very close to South Pole. Whereas in the north, we have the North Pole or the Polaris or Pole Star, which is directly pointing to the celestial north. I think, ma'am, that
Uh,
was you were trying to.
Yes, yes, yes. I kind of went off at a tangent, but
Yeah,
it's good that we got that also in. Ananya wants to know that different. See, Venus and Mercury. Venus is very bright, indecently bright sometimes. Mercury is not that bright, and also it's much closer to the sun. Of course, Venus will also go as close as Mercury is at times towards the sun. So from the
correct,
brightness, you can differentiate them. But I also want to mention that both Venus and Mercury, when you look at them through a telescope, they show phases,
correct.
right? And
That's true.
as Captain Anil was saying, that first time Galileo turned his telescope to the planets, he found this fact. And the most amazing fact about Venus, and it will be there for Mercury also, but Venus it's much more dramatic because it's so bright. You'll see that when Venus is very very bright in the sky, as I said, indecently bright in the sky, if you look at it through a telescope, it's just a thin crescent, a
Correct.
thin crescent. When it is not so bright, if you look at it through a telescope, it's full. It's full.
Yes.
That's the amazing aspect. And that actually tells us that Venus is going around the sun and we are
Correct.
outside. And so when Venus is thin crescent, it is closer to us. And when it is full, it is much further away from us. So this part is there. Very exciting about Venus. So the moment you get access to a telescope, try and look at Venus throughout the year, how you see it. Okay. There was
Ma'am,
this
if,
question.
I'm, if I may just
Yeah.
add to this, what you just said, you see, the relative size of the planets and the distance of Earth matters. Now, Mercury is about one third of the size of Earth, and
Yeah.
Venus is almost the same size. That is point number one. Point number two is Mercury is much, much farther from us, close to the Sun, and Venus is actually the nearest planet to Earth. So what ma'am just now told you, Venus would be very, very big and very bright as compared to Mercury. That is how it is. Second thing is the Venus is the brightest, thing in the sky in the morning and evening sky, and Venus also stays, far longer in the morning sky than Mercury. Mercury would disappear just within 30 minutes, or even soon along with the sunrise. So it is very difficult to see. Whereas Venus would continue maybe even after some time after the sun has risen as a very bright star. So it's once you look at it through a telescope or even the naked eye, there's no way you can confuse between Venus and Mercury. Thank you.
Yes. Yeah. And okay, so this is again a question about Southern Cross. What does it consist of and can be used for navigation accurately? You want to take that up? Not perhaps as accurately as you could do it with a pole star because it's a
Yes,
single
that's
star
right, ma'am.
towards the pole.
I'll just tell you the one point which I want to bring out here: the significance of North Pole, or for that matter, any star which is on, at the location where the South Pole the South Pole is. You see, a simple example is right now I'm sitting in Delhi, and my say latitude is 28.5 degrees north. Now, the best thing about the North Pole is that whatever is my latitude is the altitude of North Pole. A simple way to understand is the North Pole is right on top of my the North Pole. So when I go to North Pole, I would find the Polaris or North Star right on top of my head. That means at an angle of 90 degrees as I see from horizon. So when I am at the 90-degree latitude, the pole star is at 90 degrees. So as I start coming down or come to 0 degrees, the pole star actually comes to 0 degrees on the horizon. So in between whichever latitude I go to, I will find the altitude of pole star is same. So if I go to let's say Bangalore, 12 degree north, I will find pole star at 12 degrees. So that is why pole star can be seen very clearly as you go north, and as you go close to equator, it's very difficult to see it because it is going down and down. Now, this particular fact can be used for celestial navigation very, very wonderfully. That means if I identify a star to a pole star and I measure its altitude with the help of a sextant, the one position line is very clear that I am on so and so latitude. So let's say if I'm in Delhi and I know my latitude is now, if I am in India, and my latitude is 28.5 degrees, I am somewhere close to the latitude which is close to Delhi, or same thing applies when I go to other parts of globe. So this is the very simple thing which you can do. Same thing can be done with the help of Southern Cross as you go down. The names of three stars of Southern Cross, I'm not very, I don't often remember, but yes, Southern Cross is very close
Yeah.
to where the North Pole is in the northern hemisphere.
Yes. There was a question about Pluto. I'm just trying to find where is it, because I thought it would be good to discuss that. There is somebody wanted to know about pole star without sky map. How to find out pole star without sky map?
Oh,
That's
yes, ma'am.
Ananya.
I think
And while you
I should
answer this, I
have.
will try to find the Pluto question. Yeah.
Okay, I
Yeah.
should
Yeah.
have.
I think.
No, I wanted to cover that question during my the stellarium thing which I've shown you. See, basically, pole star is one star which is first of all towards the north, and it doesn't have any other star of that magnitude close to it. That is first indicator. If you start, like I told you, other indicator is the altitude. If you know your latitude, you'll always know the altitude of pole star. That means if I am at 30 degree north, and I look at a sky roughly about 30 degrees from horizon, towards the north, the star I'm going to see the pole star. That is one. Other way of looking at pole star is there's some stars which are constellations are pointers to the pole star. There's a constellation called Cassiopeia, which appears like a W or a M, depending on where you see it in the sky. Now the two stars, and if you say W, you can actually see two pyramids like this, which make two triangles. So if you draw a line from the central star of the triangle, of the upper triangle, it straight away leads to pole star. Similarly, there's another constellation called Ursa Major, or the Great Bear as we know it, or it's called Big Dipper. Because it's like a handle behind and a dipper below. It's also called Saptarishi. The four stars below become the dipper, and the three stars on top become the handle. So it's called Saptarishi in Hindi. Now, if you take the bottommost or the uppermost two stars of the Big Dipper, which are actually forming the dipper, these two stars, which are I think Merak and Duve, when these two stars, they straight away point to pole star again. So yes, ma'am. I think you can do it here. So if you see it on the stellarium, it's very easy to see. So ma'am, you have to go up north and yes. Ma'am, should I try to share my screen and do it? Yeah, okay. So we are seeing Ursa
Yeah.
Major here, and
Yeah,
ma'am, you can
I'll
explain this.
point out I'll point out the stars. You no, you please go ahead with what you're discussing. I'll point out the stars.
Okay, ma'am. So you can show the pole star first, which is pole star, which is below. Yes. So this star which ma'am is showing us now is the pole star. So now I was telling you, you see the north written below, and written below. Ma'am, below. So if you take the altitude of pole star as you go up, the degrees altitude is equal to your latitude. If you are now, let's say I told you at Delhi, latitude is 28.5, this particular angle is going to 28.5 degrees. That is first indication. Now you go to right, you see a thing Ursa Major written on top. Just at 2 o'clock from pole star, you see Ursa Major, this one. Now this is the thing on dipper on top, the two stars on top. The star which is, this star is called Mirak, the one on top. Other is Duve. So if you draw this line from Mirak and Duve, it goes straight to pole star. This is Mirak. The second star is Duve.
Mm, all right.
Ma'am, there's some GPS satellite there. You have to select it. That's why. So you draw
Yeah,
this
yeah.
line. Draw this line. It straight away goes to pole star. So ma'am, if you can show Cassiopeia on the screen, it will be the other side. And maybe you have
Yeah.
to
Well, I'll have to change the time.
you have to change the time. Yes.
Mm,
Yeah, you already was there, ma'am. Is there?
Yeah, 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 yeah.
So if you see Cassiopeia, which is in the screen again, now I told you about two triangles. So this two, the upper triangle, yes.
Obtuse,
If you
obtuse
take the,
angle one. Hmm.
yes, ma'am. If you take the center star from there, and if you
Bisect, yeah.
draw a line towards the center of the triangle, it again comes to Polaris, pole star.
Yes.
So these two
Right.
pointers, the two constellations actually point to a pole star.
Yeah, and now there was okay. Let me remove this, and I wanted to take up this question. Can we locate Pluto using telescope? Many people want to know about this. See, when Pluto was first discovered, it was I think it was using a 13-inch kind of a telescope. But
Correct.
today, but using a 13-inch telescope, it's not like look through the telescope and find Pluto there. It wasn't like that. One found a field of stars and something, and then one kind of made images over time and blinked them together. And then
Yes.
one saw that something was changing in that blink comparator, and that's how Pluto was discovered. So using 13 inch, if you have a 13, 14 inch, it's not really that simple. And even if like if you have very dark skies and you have a 14-inch and a computerized telescope and point it to Pluto, you would see a point of light. It's only when you keep taking images, and Pluto is actually having such a long orbit that since its discovery, it hasn't completed one round around the sun yet.
Correct.
So that's Pluto. And now, are there any other? Uh, uh, Let me just read what this question is. How can we justify the time of observation for stars? Many light years away with respect to the time and space gap between emission of light from star and yeah, that is true. I mean, depending on how far away the star is. If it is Proxima Centauri, which is about 4 light years away, the light leaving Proxima Centauri is coming. It's 4 years old. But if you have a star which is 100 light years away, the light coming from there is 100 years old, and so on. So we are kind of peeping back into history when we are looking at these
Definitely.
stars.
So basically, ma'am, the telescopes are basically time machines. You see, when I'm let's say looking at Jupiter, which is around 10 astronomical units away from me. One astronomical unit is the distance between the Earth and the Sun. If we take it as one unit, Jupiter is around 10 times away from me than what Sun is. So, and when I look at a moon, which is just about 30 seconds away, and let's say Jupiter and moon are close together. So when I look at moon, the light which I'm getting has left the surface of moon just 30 seconds away. And within 1 second, I move to Jupiter, and the light which I'm getting is, somewhere around 80 minutes away, for that matter, which is around 1.5 hours. So that is the beauty of it. The question to ask is how to justify. Well, I can't. I mean, there's nothing to justify. Only thing is, I can note the time of observation on Earth that I have seen a particular star at so and so time. And let's say tomorrow, the Betelgeuse, which is one of the bright stars of Orion. Now there's a thought process going on that Betelgeuse might, explode as a supernova. Now it is so far away. By the time the light reaches me, it will be some thousands of years. So basically, even if the Betelgeuse has died away, it's totally vanished from the scene. I'm still seeing it in the sky. So for me, the time of observation of supernova of the Betelgeuse, or the time of dissection of the star, will be a time which I share on the Earth with the other human beings. Otherwise, the event has happened long time back.
So I think we have all the earlier questions were answered, right? If there was anything unanswered, you could post it. But I see that mostly now there was someone expressing concern about not getting access to telescopes and difficult to buy and so on. But in that case, like what you can do is go to the nearest planetarium when they have telescope show, sky watches, or join a group of amateur astronomers, and they usually go out to locations each. They take their telescopes and share resources and so on. That would be a good way if you don't have. And in
Definitely.
any case, to beginning use of telescope, it is good to do it with a group of experienced amateurs. And Captain Anil, you have been doing a wonderful job of that, sharing your expertise with
Ma'am,
beginners.
I'll just share with the viewers here. You see, I have during COVID times, I started using the time which I had at my disposal in teaching beginners about astronomy. So we made a small group, which was basically known as the beginners group. There are many groups for astronomy in India. But this is a kind of the experienced and the skilled astronomers have come together and formed an association or a group. What we did was totally different. We said that we were going to make a group for absolute beginners, and that group we actually banned putting the photographs which are taken by the high-end cameras or the discussions which were in the realm of very advanced astronomy. We actually started discussing very basic stuff, and the group has now it got around 160 members. A WhatsApp group we started off with, and most of the members have come together to embark on a journey of learning astronomy through sharing experiences with each other. And this group has now become a very cohesive group, and here people are sharing. We are doing online stargazing sessions using WhatsApp as a medium. On a particular night, everybody logs in, and then we start looking at a night sky. People start sharing very amateur kind of photographs, which are taken with the mobile phones, which are not happening earlier. For a beginner, if you can go out, click a photograph of your own, identify object, and put in a group and get some appreciation, I think is a big morale booster. And that's what we started doing. Our aim is basically to, make this hobby very popular. The kind of video we are making are very simple videos with a mobile phone. It is just to make the hobby popular and make people understand this sort of work can also be done without very expensive equipment. So this group is already there. So those of you who would like to join it, can contact me and can be part of this group.
I can actually put the link for the WhatsApp group here in the chat. I will do that.
You can do that
And
then.
this question will probably help us to talk about a little bit of science of stars, and maybe we conclude with this. Somebody, Nagarajan, wanted to know about the colors of major stars, and the colors are actually indicative of their temperatures.
Correct.
Now, Betelgeuse and Rigel were mentioned. Betelgeuse is a red supergiant star. Rigel is a blue supergiant star. So the star, when I mean, we can actually look at their temperatures. We can find out about their temperatures by looking at the spectra of stars and so on, and colors of stars basically will tell us something about their temperatures. And also, how many stars you see of different colors reflects something about the kind of the time they spent evolving in different parts. Parts of the how they look at that time. So this is again, maybe sometime we could take this up as a science discussion.
Absolutely.
So the white stars would be the hottest ones. The red stars are relatively the cooler stars, orangish. Our sun is a yellow star, and I think we had a look at. Did we have a look at Aldebaran? Aldebaran is an orangish star. Antares is an orangish star. There's a green star, Albedo. It's greenish in color, very rare for a star like that, and so on. I think I'll just now try and share the WhatsApp group link, and with that, probably we may conclude our session today. So I'm just hunting out the group, and I will pull out the WhatsApp link. And so if and thank you,
Ma'am, I can
Captain
share the.
Anil, for that. Yeah. Or I have got it. I've just got it. I will put it in the chat now soon.
Okay.
Uh, where is this? Arey, kya ho gaya? I'm not getting the group information somehow.
Ma'am, I'll
Yeah.
send the link to
So
you. I'll
maybe
send the
what
link to
we
you.
can do is, yeah, we can do one thing. After the session is done, we can put it as a comment on YouTube, because this video will be there on YouTube, and so
You
it
can
can
do
be
that.
put there. Okay.
You can
So
do
I
that.
think so. We welcome all of you to join that. I'm also in the group, and you're doing a wonderful job there. I'm not able to spend that much time in the group, but
Thank you, ma'am.
yeah, it's a very active group. So we will end the broadcast here. Thank you, Captain Anil. It was wonderful doing this today, and thank you all of you for being there with us. And you can access this video anytime at the same link. So I'll end the broadcast now.
Thank you, ma'am. Thanks a lot. Yes, ma'am, you can.